All right, a warm welcome to today's smart class. Today we have this exponential equation before us here. It's a nice one. Here we have x to the power of 6 minus 64 equal to 0. What is the value of x here? So the power suggests the number of solutions or roots we have to solve for. So seeing what is on the board, we have to solve for 6 good roots for this math challenge here. So let's go on this journey. So here we take our solution first thing. Our solution. All right. Now look at 64. 64 can be expressed as 8 to the power of 2. And so we can rewrite the original equation to give us x to the power of 6 minus our 8 to the power of 2. This is equal to 0. Now, because we are having the power of 2 here, and here we are having 6. 6 can be expressed as 3 times 2. So let's rewrite this. So this is going to have our x to the power of 3 times our 2, then minus our 8 all to the power of 2 equal to 0. So long we are having 2 here we are having 2 here. We want to rewrite this expression here. So we're going to have this to be x to the power of 3, or in bracket to the power of 2 minus 8 to the power of 2 equal to 0. So from here, we just apply a simple law of indices, which says that if you have your a, I normally use a to the power of m, and this is equal to your a to the power of m, or in bracket to the power of n, and same thing as a to the power of your n is n, please, bracket your m here, right? Okay, so if we look at this carefully, what we have here now is same thing we have here. I'll put this in brackets, separated this from this, so I can use this to times this to give us 6 back here. So from what we have here now, we have what we call difference of 2 square. Here we have a minus this to the power of 2, this to the power of 2. So we can apply the difference of 2 square. What does it say? It says that if you have your a to the power of 2 minus your b to the power of 2, this is equal to your a plus b, bracket, 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 open again, a minus b. This is another special law, again, that we're going to apply in solving this. So I want to write this expression we have here in this format here. So rewriting this in this format is going to give us our x to the power of 3, then minus our 8, then close bracket, then bracket our x to the power of 3, then plus our 8 equal to 0. Are we in order? Yes. So whichever one that comes first is still the same thing. I decided to bring the a minus first before the plus. But the whole of this expression is equal to this. So we have two cases here now. So we're going to take case 1. We have here case 1. What is case 1? We're going to take this because according to the zero product rule, it says that we equate this to 0 and we equate this to 0. So taking the first case, we have here x to the power of 3, then minus 8 equal to 0. We can rewrite it as 2 to the power of 3. So rewriting it to the 2 to the power of 3, we're going to have this to be equal to here. We have this to be our x to the power of 3, then minus 2 to the power of 3. This is equal to 0. Another law comes in again. And this time now we have what we call the difference of 2 cubes, not difference of 2 square. So what does the difference of 2 squares say? It says that if you have your a here to the power of 3 minus your b to the power of 3, this is equal to bracket open a minus your b close bracket, then bracket close your a to the power of 2, then plus your ab, then plus your b to the power of 2 close bracket. So this is another special law we're going to make use of again. So let's roll this out here. So we can rewrite this expression in this format here now. So it also means that this is going to give us our x, then minus our 2 close bracket, bracket, our x to the power of 2 plus our 2x, then plus our 2 to the power of 2, everything equal to 0. We have another 2 cases here again now because we're going to apply the zero product rule again. So from here, we can take this as our case. Here we have case 1, so this is going to give us case 1 star. So what is case 1 star? We take the first one, which is x minus 2 equal to 0. So send this to this side, we have here x is equal to 2. So we're taking this as our x1. We've gotten the first root to this exponential challenge. All right, so let's take our case 1 star star. So we have here case 1 star star. What is case 1 star star? We're taking this, so We have x to the power of 2 plus our 2x, then plus 2 to the power of 2 will give us 4. This is equal to 0. This is a quadratic equation. We're going to use the formula method because we cannot use the factorization method here. So using the formula method, we're going to have here x is equals to your minus b plus minus the square root of our b squared, then minus 4ac. All right? Then everything all over 2a. What is our a? The coefficient of x squared, and our b is the coefficient of s, which is 2, and our constant term is 4. So if we go ahead to substitute, this is going to give us our minus, 2, then plus minus the square root of 2 to the power of 2, then minus 4 times our a is 1 times our c is 4, everything all over 2 times 1. So this is equal to minus 2 plus minus the square root of our 4, then minus 16 all over our 2 here. So let's continue here again. All right. I know most of you are wondering why I'm rushing this. I'm doing this because most persons complain of the time I spend solving my challenges or my questions on the board. But do not forget, this is a class where we are teaching students or people how to solve these things. Okay, like I said earlier on, if I'm to solve these things on my own, some of them will take me less than 30 seconds. All right, but for the sake of carrying everybody along, and this is mathematics, we don't have to rush mathematics. So for those of you that are surprised the way I'm rushing it, to make those that complain of timing, so we cannot make everybody to be happy. So let's go on and see what this gives us in time. So critically, we're going to have here our this is equal to our minus 2, plus minus, plus minus, 4 minus 16 will give us minus our 12, right? All over 2. Then this is equal to minus 2 plus minus. Here we can rewrite 12. 12 could be written as 4 times 3, right? So we're going to have here, we have, in fact, let's just split everything here, minus 1 times 4 times 3. Okay? Then all over 2. Now we know that the square root of minus 1 is equal to iota. We all know this, right? Okay, if you don't know, this is the value here. So, and here we have this to be imaginary number. So this is going to give you here minus 2 plus minus the square root of our 3, then I times our 2. Everything all over our 2 here. So from here, we can factor out 2 here. So this is going to give us here is equals to 2 into this will give us minus 1 plus minus the square root of our 3, the I, close our bracket, everything all over 2. 2 will go with 2 here. So we're going to have our x2 from here because we've gotten our x1. So have here our x2 is equal to, we're going to have this to be minus 1 plus iota into our 3. And our x3 will now be equal to minus 1 minus iota root 3. So we've gotten 3 roots from our case 1. So definitely we're going to get 3 roots again from our case 2. So let's take our case 2. So have here case 2. Where's our case 2? Remember, we had our case 1 from here. So this is our case 1. So we are taking case 2. So our case 2, we have our x to the power of 3, then plus our 8 equal to 0. Again, we can express this as 2 to the power of 3. So we have here x to the power of 3 plus 2 to the power of 3 equal to 0. Here we are going to apply the sum of 2 cubes. Here we apply the difference of 2 cubes. So how do we apply the sum of 2 cubes? Or what does it say? So we're going to see what that says in this next step here now. So from here, what does the sum of 2 cubes say? It says that if you have your a to the power of 3 plus our b to the power of 3, this is equal to bracket your a plus b, then close bracket, bracket your a to the power of 2, then minus ab, then plus our b squared, close bracket. So we can rewrite this in this format here. So that means, or thus this implies that our bracket, our x, then our plus our 2, close bracket, bracket our x to the power of 2 minus our 2x, then plus our 2 to the power of 2, close bracket equal to 0. So applying the zero product rule again, we are going to have here case 2 star. So we're going to have here case 2 of star. So yeah, we're going to have the first one we have here our x, the flux are 2 plus bracket equal to 0, right? So we have here x plus 2 equal to 0. Send this to this side, so we have x is equal to minus 2. So we have this to be our x4. So we have this to be x4. So we take our case 2 star star. So what does this say? It says our x to the power of 2 there minus, please. So we have your x to the power of 2 minus 2x there plus our 2 to the power of 2 equal to 0. So we have x to the power of 2 minus 2x there plus our 4 equal to 0. Again, this is a quadratic equation. So yeah, we have to use quadratic formula again to solve this. So yeah, we're going to have our x is equal to our minus b plus minus the square root of our b squared minus 4ac all over 2a. So from here, let's continue on this side. Let's see what this gives us in 10. So here we're going to have our x will now be equal to, what is our b? Our b is minus 2. So we're going to have this to be minus bracket minus 2 close bracket plus minus the square root of our minus 2 all to the power of 2, then minus 4 times our 1, then times our 4. Write everything all over 2 times 1. Okay, so this is equals to our 2 plus minus the square root of our 4, then minus 16 all over 2. This is equals to 2 plus minus the square root of minus 12 all over 2. From here, from what we did the other time, this is going to give us our iota root 3. Okay, so this is going to give us 2 plus the square root of 2 iota root 3. Rather, so it's 2 iota root 3 all over 2. So if we factor out 2, we're going to have here 2 into 1 plus minus our iota root 3, then all over 2. 2 goes out here. So we now have our x5 will now be equal to our 1 plus iota root 3, and our x6 will now be equal to 1 minus iota root 3. Wow. So these are the 6 roots to our exponential equation. Okay, so the first one was x equal to x1 is equal to, is it minus 2 or positive 2? It's positive 2. Okay, so this is our x1. Look at our x2, x3. Then look at our x4 and our x5, x6. So these are the 6 roots to this nice exponential equation. So this brings us to the end of this math class. If you learned something from this video tutorial, then give the video a thumbs up. And if you're not playing any of these steps here, then drop it in the comment section. We'll reply to you. Thanks once again. And until we meet you in our next class, keep winning. Remember, All I Must TV loves you dearly. Most especially Jakes himself loves you dearly. Bye for now.